Hello, I'm Tom Billigen, and I want to share with you some new EFI information. We have one new system on board this year, and it's called EFI with ETC. ETC is an acronym for Electronic Throttle Control, a new EFI system to Briggs & Stratton and Vanguard lineup for model year 2020 and 2021. We have teamed up with Continental to provide the components for this new system, specifically for V-twins. This new system is aimed at maintaining peak engine performance and improved productivity through precision engine speed control unmatched by a conventional mechanically governed system. The system utilizes an electronic throttle body, otherwise known as drive-by-wire. The standard throttle control on the dash of the machine would essentially operate in the same way as perceived by the end user. A throttle lever, rotary dial, or momentary switch can be used to manage engine speed. The standard idle and top no-load speeds, along with infinitely adjustable mid-range speed, would be available just like a mechanical throttle and mechanically governed engine. The system takes much of the laziness that comes along with a mechanical governor out of the system and provides a very instant and powerful response to engine loads. The difference in engine RPM droop is approximately 50 RPM versus 150 plus RPM of the mechanical system. If we can envision using the cruise control in your vehicle to help understand what ETC does. The vehicle is equipped with a mechanical governor in the first example. If you set the cruise control at a speed of 55 miles per hour and the vehicle encounters a hill or engine load, the vehicle speed is allowed to fall back to 50 mile an hour before it responds and brings it back to 55 mile an hour. The second example is of a vehicle equipped with ETC. In the same situation with the cruise control set at 55, the vehicle encounters the same hill, only now the vehicle slows to 54.5 mile an hour before responding and bringing it back to 55 mile an hour. The ETC system provides the instant speed control that you would expect and allows you to maintain consistent ground speed and blade tip speed. Another example would be a drag race between two lawnmowers cutting heavy wet grass. Both machines are equal except one is mechanically governed and the other is ETC equipped. Using full ground speed while cutting the heavy wet grass, the ETC equipped machine starts to pull ahead instantly and continues to increase its lead over the length of the yard. In fact, it's able to turn around and start a return cut path before the mechanically governed machine has reached the end of the yard. You can see clearly how this system would aid in cutting productivity for professionals. The first family of engines you will expect to see ETC on are the Model 44 and 49 V-twins, both professional series and commercial series. These will be 25 and 27 horsepower respectively. These engines will be open loop, so there'll be no oxygen sensor in the exhaust to aid in versatility in different applications. You can still expect up to 15% fuel economy improvement over the carbureted engines. These engines will be showing up on some Simplicity products this year. The next engine is the Model 61 vertical shaft big block. The 40 horsepower will be launching with Ferris on the ISX 3300 model. This will be an oil guard only unit in this application. This engine is closed loop and you can expect the usual up to 25% fuel economy improvement over that of the carbureted engine. The 40 horsepower engine gets their horsepower increase over the 37 from internal changes, mainly an increase in compression ratio and a high output camshaft. At this time, no other OEMs have elected to take either engine family for 20 and 21 model years. These engines are not exclusive and are available to OEMs into the future. The short answer, there is a lot that's different. To start with, there will be some changes to the service tools we offer. The Tiny Scan as it stands will not work on this new system. We are currently working on a universal Tiny Scan that will work on all of our EFI systems, which are Delphi, Mala, and Continental. The most current diagnostic tool for laptops, part number 19636, does in fact work seamlessly on this new system as long as you have let the software update to version 3.1 or newer. A ETC-specific service manual is currently under construction and will be placed on the Power Portal under the EFI Resources tab once it's complete. This manual will be available in electronic-only form and can be downloaded to your computer. The communication method has changed when compared to the Delphi system. This system uses CAN SAE J1939 spec for communications. CAN, or Controller Area Network, brings us current with heavy-duty on- and off-road diagnostic systems and allows for seamless integration of the engine into the neural network of an advanced piece of equipment. The largest change for the technician is how we interpret the diagnostic code strategy. The DTCs are now a two-part and are called SPN and FMI. SPN stands for Suspect Parameter Number. It's the code that calls out the specific component that is having a fault. Think of this like a zip code. FMI stands for Fault Mode Identifier, and this is how that component has failed in particular. This is like an address. The CAN system also brings a new set of issues and troubleshooting requirements. If this system gets interrupted by outside means, like CAN wires are shorted to power or ground, it will cause some very interesting engine performance issues. Unfortunately, with how small the voltages are and how fast the system operates, we need some sophisticated tools, like an oscilloscope, to diagnose problems with it specifically. Engine wiring harnesses have been simplified and improved for assembly and packaging on the engine. The use of abrasion-resistant tape instead of convoluted loom really helps reduce the bulk, and there is far less wiring involved with this system as well. The ECM is integrated into the side of the throttle body. One wiring harness connector, which is a 32-pin connector. The MAT, manifold air temperature, and MAP, manifold absolute pressure sensors, are now integrated into the throttle body. None of these parts are serviceable. If they are deemed failed, a new throttle body and ECM go on to repair it. The ECM will be shipped blank, just like the Delphi system, and will require flashing a calibration into it based on the engine serial number. The 19636 diagnostic tool is needed to complete this task, and the flashing functionality is supported with this tool on the Continental system. All the IPL or illustrated parts lists and service part information is currently available in eParts on the Power Portal. Service replacement engines are also currently in progress so that there are complete replacements available for warranty as needed. Electronic training classes for ETC will be created very soon, and there will be several video segments covering everything you need to know to successfully troubleshoot and repair this system. Let's take a brief look at some of the components that are carried over and new parts in the ETC system. For example, we will focus on the 40 horsepower ETC engines. The existing parts that carry over from the Delphi system are as follows: the 23X flywheel, the speed sensor, lift pump, high pressure fuel pump module, fuel injectors, fuel rail, and O2 sensor. New parts specific to the Continental ETC are as follows: intake manifold, throttle body with ECM, wire harness, ignition coils, and fuse and relay box. As mentioned before, the throttle control at the dashboard of the machine is the biggest difference with the system. The engine speed can be controlled by two different methods. The more common approach is the throttle control on the dash that changes resistance. This uses an analog input that works with the 5 volts supplied by the ECM through the main vehicle connector. The throttle control mechanism accepts 5 volt input and can variably change the voltage returned to the ECM based on the operator demand. This reduced voltage can be interpreted by the ECM directly to a target engine speed. Whether it's a lever, rotary dial, or momentary rocker switch, the system can change speed on demand. The other way engine speed can be managed is via the CAN bus system. Obviously, this is reserved for more advanced applications. A message can be broadcast from the equipment through the CAN high and low wires to the ECM, and an engine speed can be changed just like if we move the manual lever. The fuel system is generally the same as the Delphi on both engine families. The only major changes are to the Model 44 and 49 engines, where the lift pump is moved to the rear corner of the engine and the vacuum signal from the valve cover is extended to it. The fuel rail also becomes external on this engine family instead of molded line like that of the A10 Vanguard EFI engines. The short answer is no at this time. These engines are only offered as an OEM-placed engine at this time. There are some hurdles to overcome first. Service, throttle controls, and wiring harness to connect the engine and throttle control are one. The engine plugs are different now too. They are a 16-pin Molex brand sealed connector. The weather-tight sealing of this plug is now critical with CAN and 5-volt throttle wiring passing through it. Currently, the new 40 horsepower ETC is an oil guard only specification, so a wet sump spec would have to be created first to make repower easier. As time goes on and these engines make their way onto more OEM applications, it will then make sense to offer repower versions of these engines with a whole host of accessories to make them integrate into older non-EFI equipment easier. I hope this brief look at the new ETC system was helpful and gives you a little more insight as to what to expect from this system if you encounter them over the next year. Again, keep a lookout for specific online training classes on the ETC system in the near future. We will make sure to advertise it on the Power Portal as well. Thank you for watching.